Welcome to A-Star Science, part of our GCSE Must Know Chemistry series. Today we're going to be talking about bonding for GCSE, the four main types of bonds that you need to know about. Make sure you like and subscribe. Please let me know what videos you'd like me to do. Leave a comment in the comment boxes below. So what are the four types of bonds that you need to know? Now, this always comes up in paper one. They love to ask questions on this topic, so make sure that you're paying attention. The four types of bonds are covalent, ionic, metallic, and giant covalent. And we're going to talk about each one of those, what they are, and what their properties are. So let's start with covalent. Covalent is bonding between two or more nonmetals. Two or more nonmetals. That's what covalent is. And in this case, in covalent bonding, electrons are shared. Ionic bonding is bonding between a metal and a nonmetal. In this case, electrons are transferred, meaning lost or gained. Metallic, on the other hand, is bonding between metals, the same type, and are surrounded by a sea of delocalized electrons. And I'm going to go over examples of each one of these in a minute. Delocalized electrons. Now, giant covalent is very similar to covalent, is bonding again, like covalent, between two or more nonmetals. The difference is this is in a giant lattice. We're going to talk about what that is in a giant lattice. So let's give some examples. So covalent, we said, is bonding between two or more nonmetals. An example of covalent, for example, would be hydrogen gas, which is diatomic. So you can see it's two hydrogens. That is covalent because there's two or more nonmetals. Ionic, for example, sodium chloride is a good example. You have a metal, sodium, and a nonmetal, chlorine. An ionic have charges, so this would be a plus charge, this would be a minus charge. Hence why we call it ionic bonding, because there are two ions involved. Metallic, for example, let's say we had a block of iron, and Fe is the symbol for iron. Well, what that would look like at the atomic level would be atoms of iron all lined up. And between those atoms of iron, you would have electrons, which are free to move, which we call delocalized electrons. These would have a charge, by the way. You can just put a plus charge because metals have positive charges. And giant covalent, a good example, is between two or more nonmetals. The examples you hear about a lot will be diamond. So diamond looks like this as a structure. You have these carbons, and each carbon is bonded to four other carbons. And that will just continue to grow and grow and grow in what we call a lattice structure, which is a regular arrangement of atoms. So covalent they tend to have low melting points. We know that because most of them are gases. And why? That's because between the molecules, there are weak forces, which we call weak intermolecular forces. So if I had a molecule of hydrogen in a room, there's going to be many more around it. I know it's covalent because the electrons are being shared between two or more nonmetals. But between these molecules, we have very weak forces, which I'm using lines to show. Okay, very weak forces, so they're easy to overcome. Ionic, on the other hand, they have high melting points. They don't have weak forces. They actually have very strong electrostatic forces of attraction. The reason for this, if we look at the sodium chloride again, sodium is a +1 ion, chlorine is a -1 ion. So between these two atoms, you have some really strong, I'll put this in red, some really strong electrostatic forces keeping them together. Metallic bonding. This also has very high melting points. Many of the saucepans and things we use to cook are made from metals, so we know that they have a very high melting points. Again, this is due to the strong electrostatic forces. And let's look at a diagram of metal to understand why they have strong electrostatic forces of attraction. If I was to draw a lattice, a metal lattice, let's say I was using iron, which has a plus charge. There's going to be a lot of these atoms of iron because we know atoms are quite small. And between that, you're going to see these electrons that are free to move. That means that the positive atoms are attracted to the negative electrons. And that's what we call strong electrostatic forces of attraction. And then we have giant covalent. This has the highest melting point of them all. Anyone knows about diamond, we know that diamond has a very, very high melting point. Very high. Even higher than ionic. And there's a reason for that. And that's because they have many strong covalent bonds. Because remember that giant covalent is in a lattice. So if I was to draw a diamond, for example, these lines that I'm putting, these straight lines, these are the covalent bonds that are going to be bonding each carbon to each other. And they're very strong. Okay, these are the covalent bonds, and they have many of them, and they're very strong, giving it a very high melting and boiling point. We can also look at the electrical conductivity, the properties. You need to know this for the exam as well. And let's first look at covalent. Covalent are not good conductors. They do not conduct electricity. Most of the time, these are gases, but they do not conduct electricity even when they're solids. That's because there are no charged particles. All the electrons are caught up in those bonds that we talked about. So it does not conduct electricity. They form these simple molecules. Hydrogen is an example. Carbon dioxide is another example. And so we can see that the electrons are located in the bonds. And that means that there are no charged particles free to move. Ionic now, they do conduct electricity. But there's a catch. They conduct electricity, when molten, meaning when they're liquid, or dissolved in water. The reason for this is that when they're dissolved or molten, they have mobile ions free to move. Not electrons, mobile ions free to move. It's very important that in the exam, if they ask you, you write the term mobile ions. And if we look again at sodium chloride as an example, as a solid, these ions will be locked in like that. We know that solids have this compact fixed arrangement. But if they were a liquid, then these ions, especially the negative chlorines, would be free to move around. And that would mean it could conduct electricity. When it comes to metallic bonding, we know that metals are very good conductors. And what's the reason for that? Well, remember we said for something to be a good conductor, they have charged particles. In this case, delocalized electrons. And these electrons are free to move because they're delocalized. So for example, if I draw iron and a metallic lattice of iron, we will have these positive metal ions. But of course, in that lattice, it's also going to have these negative electrons that are free to move. And this can occur even if it's a solid or a liquid. And then finally, giant covalent. Some of them can conduct electricity. So diamond, no, is not a good conductor. No. Why? Again, no charged particles. Whereas graphite, yes. Why? Because it has delocalized electrons. And we're going to look at that a little bit closer. So here we have diamond. If you notice when I draw a diamond, every carbon is bonded to 4 other carbons. Now carbon is in group 4 on the periodic table. That means it can only bond to 4 other things. That means for each electron that the carbon has, if this was the carbon, it would have 4 electrons. It's now bonded to 4 other things, 4 other carbons, which I'm showing here in red. That means it has no free electrons that are free to move and carry a charge. Graphite is different. Graphite you often see drawn like this, and it's bonded to 3 other carbons each. So if you look at this central graphite here, it's bonded to 3 other carbons. That means it has a 4th electron that's free to move and carry a charge. So diamond is it doesn't conduct. It's not a conductor of electricity. Whereas graphite is yes. And that applies to not only graphite, but graphene and carbon nanotubes, which you sometimes see called fullerenes. So again, let's summarize the 4 types of bonds that we need to know. There is covalent, which is bonding between 2 or more nonmetals in which electrons are shared. There's ionic, bonding between a metal and a nonmetal. Electrons are lost or gained in this type of bonding. There's metallic, which is bonding between metals of the same type of atom, surrounded by a sea of delocalized electrons. There's giant covalent, which is bonding between 2 or more nonmetals because it is covalent, but in this case, they form a giant lattice. Covalent, remember, they have very low melting and boiling points. and they do not conduct electricity. Ionic, they have high melting and boiling points, but they do conduct electricity when they're dissolved or molten. Metallic has a high melting point because they have strong electrostatic forces of attraction between the metal ions, and they do conduct electricity because they have the delocalized electrons. And giant covalent has a very high melting point, and only diamond and graphite. Graphite is the only one that will conduct electricity. Make sure you study these, in particular the properties of the bonding, whether they conduct electricity and what the melting and boiling point is like, because they love to ask you this topic in the exam. Please make sure you like and subscribe, leave a comment, let me know which videos you'd like me to do.